a solidly grounded system, a ground fault results in a very high current flowing through the fault path. This high current can cause the fire pump to explode or catch fire, which could worsen the situation and potentially cause fatalities. The requirement for ground fault protection in fire pumps is based on the following reasons. Firstly, high energy release. A ground fault in a solidly grounded system releases a significant amount of energy, which can cause catastrophic damage. Secondly, fire hazard. The sparks and heat generated during a ground fault can ignite nearby combustible materials, leading to a fire. Thirdly, electrical shock. A ground fault can create a path for electric current to flow through the pump housing and into the ground, posing an electrocution hazard to personnel. While the National Electrical Code, or NEC, generally requires ground fault protection for all electrical systems, there are exceptions for fire pumps. However, these exceptions should be carefully considered and applied only in specific circumstances. Firstly, ungrounded systems. Fire pumps supplied from ungrounded systems do not require ground fault protection because there is no ground path for fault current to flow. Secondly, isolation transformers. Isolation transformers can be used to isolate the fire pump from the grounded system, allowing it to operate safely without ground fault protection. Considering the potential hazards of ground faults in fire pumps, it is generally advisable to provide ground fault protection in all cases. This can be achieved through the use of circuit breakers, ground fault interrupters, or GFIs, or other suitable devices. By implementing proper ground fault protection, the safety and reliability of fire pumps can be ensured. Ground fault protection is crucial in electrical systems to prevent damage and hazards from unintended electrical paths to ground. When a ground fault occurs, a significant amount of current can flow through the fault path, potentially causing equipment damage, fire, and electrical shock. In fire pump systems, the consequences of a ground fault can be particularly severe. Fire pumps are critical for providing water to suppress fires, and their failure during an emergency can have devastating results. Therefore, understanding ground fault protection and its application in fire pump systems is essential. Let's explore the fundamentals of ground faults, the importance of ground fault protection, and the specific requirements for fire pump systems. A ground fault occurs when an unintended electrical path develops between a live conductor and ground. This can happen due to insulation failure, accidental contact with grounded objects, or other causes. In a solidly grounded system, the neutral point of the power source is directly connected to ground, providing a low impedance path for fault current to flow. When a ground fault occurs in such a system, a large amount of current can flow through the fault path, limited only by the impedance of the circuit and the fault itself. This high current can cause significant damage to equipment, including fire pumps. The high current can generate heat, which can ignite nearby combustible materials. Additionally, the current can cause arcing and sparking, which can also ignite fires. Furthermore, the current can damage the fire pump motor and other components, rendering the pump inoperable. The primary purpose of ground fault protection is to detect and interrupt ground faults before they cause significant damage or hazards. Ground fault protection devices, such as ground fault circuit interrupters, or GFCIs, and ground fault relays continuously monitor the current flowing in the circuit. When a ground fault is detected, these devices quickly trip the circuit breaker or activate an alarm, isolating the faulty circuit and preventing further damage. Ground fault protection is particularly important in fire pump systems due to the critical nature of these systems. A fire pump must be reliable and available when needed to provide water for fire suppression. A ground fault can disable the fire pump, leaving the building unprotected in the event of a fire. To ensure the reliability of fire pump systems, the National Electrical Code, or NEC, provides specific requirements for ground fault protection. These requirements are designed to minimize the risk of ground faults and ensure that fire pumps are protected from damage. The NEC generally requires ground fault protection for all electrical systems operating at voltages above 150 volts to ground. However, there are exceptions for fire pumps, recognizing the unique requirements of these systems. One exception is for fire pumps supplied from ungrounded systems. In an ungrounded system, there's no direct connection between the power source and ground. As a result, a single ground fault will not cause a large current to flow. Instead, the fault current will be limited by the impedance of the system, typically to a relatively low value. Because the fault current is limited, there is less risk of damage to the fire pump. Therefore, ground fault protection is not required for fire pumps supplied from ungrounded systems. Another option for protecting fire pumps from ground faults is to use an isolation transformer. An isolation transformer is a transformer that electrically isolates the fire pump from the grounded system. The primary winding of the transformer is connected to the grounded system, while the secondary winding is connected to the fire pump. Because there is no direct electrical connection between the primary and secondary windings, a ground fault on the primary side will not affect the fire pump. Isolation transformers can be used to create an ungrounded system for the fire pump, even if the main power source is grounded. This allows the fire pump to operate safely without ground fault protection. In addition to the exceptions for ungrounded systems and isolation transformers, the NEC also provides specific requirements for ground fault protection of fire pumps in solidly grounded systems. These requirements are designed to minimize the risk of damage from ground faults while still allowing the fire pump to operate reliably. The NEC requires that ground fault protection devices used in fire pump systems be specifically listed for fire pump service. This ensures that the devices are designed to withstand the high currents and other stresses that can occur during a fire. The NEC also requires that ground fault protection devices be tested regularly to ensure that they are operating properly. This testing should be performed by qualified personnel and should include verifying that the devices trip within the specified time limits. In addition to the NEC requirements, there are other factors to consider when selecting and installing ground fault protection for fire pump systems. One important factor is the sensitivity of the ground fault protection device. The sensitivity should be set as low as possible to detect ground faults quickly, but not so low that it causes nuisance tripping. Nuisance tripping can occur due to normal leakage currents in the system, which can be misinterpreted as ground faults. Another factor to consider is the coordination of ground fault protection devices. In systems with multiple ground fault protection devices, it is important to coordinate the devices so that they trip in a logical sequence. This ensures that the fault is isolated quickly and that the rest of the system remains operational. The coordination of ground fault protection devices can be complex, and it is often necessary to consult with a qualified electrical engineer to ensure that the system is properly designed. In conclusion, ground fault protection is essential for protecting fire pump systems from damage and hazards. While the NEC provides exceptions for ungrounded systems and isolation transformers, it is generally advisable to provide ground fault protection in all cases. This can be achieved through the use of ground fault circuit interrupters, or GFCIs, ground fault relays, or other suitable devices. By implementing proper ground fault protection, the safety and reliability of fire pumps can be ensured. Remember that fire pump systems should be inspected, tested, and maintained regularly to ensure their reliable operation. This includes regular testing of ground fault protection devices. A properly maintained fire pump system is essential for protecting lives and property in the event of a fire. When dealing with electrical systems, always adhere to the National Electrical Code, or NEC, and local electrical codes. Ensure that all work is performed by qualified personnel who are familiar with the NEC requirements and safety procedures. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. Solidly grounded systems, while providing a direct path for fault current, can also pose risks, especially with equipment like fire pumps that need to remain operational during emergencies. The high fault current in a solidly grounded system can cause significant damage to the fire pump motor, control equipment, and wiring, potentially leading to a complete failure of the fire pump when it is most needed. This is why understanding the exception to ground fault protection requirements specifically for fire pumps is critical. The NEC recognizes that shutting down a fire pump due to a ground fault, even a temporary one, could be more dangerous than allowing it to continue running with a ground fault present. The code makes provisions to allow fire pumps to operate without ground fault protection under specific conditions, aiming to ensure the pump's availability during a fire emergency. However, this doesn't mean ignoring the risks associated with ground faults. The exception to ground fault protection for fire pumps in the NEC is a carefully considered balance between the need for continuous operation and the risks associated with ground faults. While the NEC allows for the omission of ground fault protection, it also emphasizes the importance of alternative protective measures and careful system design. It is crucial to understand that the decision to omit ground fault protection should not be taken lightly and must be based on a thorough engineering evaluation of the specific fire pump system. One of the primary alternatives to ground fault protection is to supply the fire pump from an ungrounded electrical system. In an ungrounded system, there is no intentional connection between the electrical conductors and ground. This means that a single ground fault will not result in a high fault current, as there is no return path for the current to flow. The fire pump can continue to operate with a single ground fault, providing continued fire protection. However, it is important to note that an ungrounded system is not completely immune to ground faults. A second ground fault on a different phase will create a complete circuit and result in a high fault current. Therefore, it is essential to have a ground detection system in place to alert personnel to the presence of a ground fault so that it can be located and repaired promptly. Ground detection systems typically use ground detectors or ground fault indicators to monitor the system for ground faults. These devices can provide visual or audible alarms to alert personnel to the presence of a fault. Another alternative to ground fault protection is to use an isolation transformer to isolate the fire pump from the main electrical system. An isolation transformer provides electrical isolation between the primary and secondary windings, preventing ground faults on the primary side from affecting the fire pump on the secondary side. The isolation transformer can be configured to create an ungrounded system for the fire pump, providing the same benefits as an ungrounded system. However, it is important to note that the isolation transformer must be sized appropriately to handle the fire pump's load and must be installed in accordance with the NEC requirements. When designing a fire pump system without ground fault protection, it is essential to consider the following factors. Firstly, system grounding. Determine whether to use an ungrounded system or an isolation transformer to isolate the fire pump from the grounded system. Secondly, ground detection. Install a ground detection system to alert personnel to the presence of a ground fault. Thirdly, overcurrent protection. Provide adequate overcurrent protection to protect the fire pump motor and wiring from overloads and short circuits. Fourthly, selective coordination. Ensure that the overcurrent protection devices are selectively coordinated to minimize the extent of any power outages. Fifthly, regular maintenance. Implement a regular maintenance program to inspect and test the fire pump system, including the ground detection system and overcurrent protection devices. Finally, documentation. Maintain accurate documentation of the fire pump system, including the system design, equipment specifications, and maintenance records. The decision to omit ground fault protection for a fire pump is a complex one that should be made in consultation with a qualified electrical engineer. The engineer will need to evaluate the specific fire pump system and consider all of the relevant factors, including the system grounding, ground detection, overcurrent protection, selective coordination, regular maintenance, and documentation. By carefully considering these factors, the engineer can design a fire pump system that is both reliable and safe. It is also important to note that the NEC requirements for fire pump systems are constantly evolving. It is essential to stay up to date on the latest code changes and to ensure that the fire pump system complies with all applicable requirements. The NEC is updated every 3 years, so it is important to review the latest edition of the code to ensure compliance. In addition to the NEC requirements, there may also be local codes and regulations that apply to fire pump systems. It is important to check with the local authorities to determine what requirements apply to the specific fire pump system. By following the NEC requirements and local codes, you can help to ensure that the fire pump system is both reliable and safe. Ground fault protection for fire pumps is a critical safety consideration, balancing the need for operational reliability during emergencies with the risks associated with high fault currents. While the NEC allows for exceptions to ground fault protection requirements under specific conditions, it is essential to thoroughly evaluate the system and implement alternative protective measures. This includes carefully considering the system grounding, ground detection, overcurrent protection, selective coordination, regular maintenance, and documentation. By working with a qualified electrical engineer and staying up to date on the latest code changes, you can help to ensure that the fire pump system is both reliable and safe, protecting lives and property in the event of a fire. Remember that electrical safety is paramount, and all work on electrical systems should be performed by qualified personnel who are familiar with the NEC requirements and safety procedures. Regular inspections, testing, and maintenance are essential for ensuring the continued reliability and safety of fire pump systems.